Hey, this is Rez for Voxsite.com bringing you another Copernicus tutorial. This time we'll create a broken tile texture and also create a simple scene in Solaris and render with Karma. If you want to learn how Houdini is used on real-world projects, be sure to check out our courses on Voxsite.com. Let's get started. Let's get started and we'll create a new COP network. Let's go ahead and just leave the settings as they are and we'll step inside. So we'll drop down a preview material to begin with, and let's start with the first and most important node here, which will be a tile pattern. And let's preview this pattern. And for the divisions here, 10 will be just fine. So we can use as many tiles as we want, but we can just keep this at the default of 10 and increase it later if we want. We want to introduce some randomness for all of the position, scale, and rotation values. So let's start with the position, and I'll enable uniform jitter here. And let's just reduce this to maybe 0.02 or maybe even less. We just want to very slightly displace all of the tiles as far as the position is concerned, and we can also introduce some rotation variation. We'll set this rotate tile here, let's set varying, and maybe we just want maybe 4 degrees or so, should be just fine, maybe even less, we can use maybe 3.5. And for the size, let's go ahead and also set varying on our uniform scale and just introduce a little bit of variation. Let's maybe try 0.1 variation, and we can see now that this kind of makes all of the tiles quite small. So we want to compensate a little bit for this decrease in the size, and I'll increase the uniform scale here to maybe 1.05. So I kind of want some of the tiles to sort of intersect between each other, sort of like they're on top of each other, and this will create a nice natural distribution. So we can plug this result right away in our preview surface material. Let's plug this in our height and let's go to our preview material. So here we want to increase the divisions. We need at least a value of 500 so we are able to judge exactly what kind of textures we are creating. Let's also go in the displacement options here and let's turn down the high scale quite a lot. Let's maybe set this to 0.1 to begin with. For the color, I'm just going to set this default color. I'm just going to lower the overall value here, and we'll come back later for the color. Maybe we want even less scale in our height. Let's try 0.05 for now, and this should be fine as our starting point. So the first thing that I want to do here is introduce a slope that's random per each individual tile. So we want to create a ramp. If we just put down a ramp mono and we plug this into the height, we can see in our preview material that we have this slope. If we look from the side, we can see that this height goes from 0 to 1 across our ramp. So we want to map this for each individual tile. So if we grab our UV over here and plug this in the position, this will now repeat our ramp per individual tile, and our result will be something like this. And now we want to rotate this ramp per each individual tile, so we can drop down a UV transform. Let's drop this here and I'll plug the UV inside the UV. We'll plug this back in our position for the ramp, and for this UV transform here we can now play around with the rotation. We can see how our slope changes per individual tile as I increase the rotation, so we want to randomize this, and we can use the ID that our tile pattern provides. We can preview this ID if I set the display over here to ID, so we can see that this is a random value for each individual tile. And let's set this back to tiles. We'll place the ID as our seed, and now our UV transform will have a different rotation per each individual tile. We might also want to scale this UV per tile. So if we go back to our ramp and let's actually preview the material, we see that we have these hard cutoffs here around the corner, and we can compensate for this if we just increase our uniform scale mean and max. So if I increase, or rather decrease in this case, we can decrease the uniform scale max, and also I will decrease the uniform scale mean just until we get rid of those cutoffs around the corners. So we end up with something like this, and now we can see this nice variation in all of our tiles. We can go back to our UV transform. So now, for example, I can change change the seed if I want to randomize this ramp per individual tile, which is really great. And one more thing that I want to do is also just overall drop down the scale, or rather the height of each individual tile. So I'll grab my ID from the tile pattern. We'll drop this inside a random mono. Let's plug this as our ID. So we have the 0 to 1 value per tile. And now we can use this map here to multiply with our ramp. So let's plug our random mono inside a multiply after our ramp, and maybe I'll make some more room over here so we can visualize our node tree better. And also I'll press Shift S so we get this curved wiring. So if we go back to our preview material now, with this multiply with the random mono, we have a variation in our height as well. And we might want, let's go to our color here. We might want to increase this color, and maybe in the specular, let's go ahead and increase the default roughness for now. So this should be good for now. Let's go ahead, and one final thing that I want to add for my base shapes, we can actually grab all of these nodes, and I'll press Shift O to draw a network box, and I'll rename this to base shape. And one final thing that I want to do here is also just introduce a little bit of noise overall for our tiles. We can just drop down a simple fractal noise, preview this, and we can just multiply this over our current result. Let's go ahead and let's plug this in our background. So this is what we get. This is a little bit too much. We can also do a remap after our fractal noise, and let's maybe just increase the output mean here so we don't introduce that much noise. We can zoom in a little bit and we can see that this is the result. So with this new noise, it's probably not that noticeable, but we do have a little bit of variation in our tiles. So just a little bit of base texture going on for now. We will also need to increase the output resolution on this. So we can see that this is currently at 1K resolution. We will increase this to 4K so we will get a lot sharper details, but I like to do this towards the end or after I get a really good approximation of the final texture that I'm going to export. Because if we increase the resolution now, it might slow down our network, and it's not really worth increasing it at this point. So the next step that I want to do is widen the gap between each individual tile and also introduce some noise around our tiles by using this gap. So we can go back to our tile pattern, and what we want to do is isolate the gaps between our textures. So I'll grab the tiles here and I will do an invert. So we have white that's between our tiles, and what I want to do with this texture is try to widen it a little bit so we can drop this inside an dilate erode node, and we can see that the default here, let's set this soft edge to 1, and we can use this radius value here to either expand or contract our borders. So what we want to do, instead of setting this as a uniform value, we can use a fractal noise to drive our radius instead. So I'll plug the noise inside the radius, and I'll set this radius here to 25, and in our fractal noise settings I can play around with the amplitude and the center here, and we can see how we only get this expansion in certain areas. So this is what we want. Maybe I'll increase the center a little bit more, and I can also play around with the roughness and noise settings. Also maybe I'll decrease the element size a little bit. Let's use maybe 0.05, or let's actually increase this slightly. Let's do something like this. So this is the erode on top, and we can now subtract this from our height, and we can go to the multiply here. Let's drop down a subtract, and let's plug our dilate erode in the foreground, and now this is the result. If we go to the height, we can see this here in action. So we get a lot of cool details around the borders of our tiles. Also, this subtraction operation here kind of gives us values in the negative ranges. So I just want to work with values that start from 0, at least in terms of height. So all we have to do here is just drop down a clamp and make sure that this is clamped to the lower limit of 0. The upper limit we can probably disable this. But we do want the lower limit to 0, so we don't have negative values. And now if we go to the result, we can see that we push this texture, or rather the height, in the negative ranges here. So I want to avoid this if possible. And now to also compensate for the overall height, I can go to the preview material here and I can maybe just increase slightly our height scale to maybe 0.07. So we end up with something like this, and I can go back to my, let's go to the fractal noise for this dilate node, and we can continue to play around with our amplitude here. We might want to increase this, but maybe not so much. Let's leave this at 1, and we can play around with the center here and also the contrast. We can kind of see the different results that we get. Let's play around with the element size as well. We might want to reduce this to 0.065, and this should be fine, and we can keep going. Let's isolate our dilate node, and we want to introduce a little bit of extra roughness around these edges. So from here we can do a distort by slope, and usually I use the distort with the slope direction when I want to maintain the overall shape that I have and just introduce a little bit of distortion, rather than just using the regular distort without the slope direction, which tends to alter the base shape a little bit too much. So with our distort and the slope direction, let's set a fractal noise and plug this in our slope here, and let's preview the result. So we can go to the fractal noise, or actually let's go to the slope there and let's reduce the scale. And for the fractal noise, we can play around with the scale here as well. We might reduce the element size, and we might want to reduce the roughness just a little bit. But we can see that with this extra layer of distortion, we just introduce a little bit more roughness around the edges, and we keep most of our shape that we got with the dilate erode. So now the final result should look something like this. Finally, I also want to smooth out this transition between 0 to the full value. So I'll just introduce let's do a blur after our second distort, and we can keep this at the default settings. We can see that this is a fairly low value, but with this blur, it just helps to smooth out this transition a little bit. Maybe this is too much. We might use 0.003. And also this will be more noticeable when we increase the resolution overall. But for now, I'm pretty happy with this result. Again, we can see with and without our erosion here. This is what we get. So we can grab all of these nodes. Let's press Shift O, and this will be our border erode, and we can move on. The next step here would be to create per tile erosion. So similarly to how we did our border erode, I want to create one layer that will actually erode each entire tile. So in order to do this, we can start again with the same setup that we had for our base shape. So I'll grab the UV transform and the ramp. I'll copy these nodes and paste them over here. So we have the same base. Now it's worth randomizing the seed for this layer. So let's just choose another seed here. And I want to use this to drive the erosion, but we want to introduce some noise along the gradient here. So what we can do is drop down a fractal noise, and I will do, let's drop down a blend. And the blending mode that I want to use here is burn. So burn will allow us to have this noise in between the 1 and 0 values, so it's mostly going to affect these gray values here in the center that are roughly 0.5. And I'll show you what I mean by this. If I plug the fractal noise in the BG, we can see this is the result that we get. And now I can go to the fractal noise and I can control the element size, but probably we want something rather small. And by decreasing the amplitude, we can see how we can determine the amount of distortion that we want to have. And also we will probably need to scale the UVs for some of these styles. So I'll go in my UV transform here, and let's go ahead and actually increase the uniform scale min and max. So let's just plug this in our chain and see what we get. We would want to subtract this. So from our subtract here, I'll grab the clamp and my preview surface, and let's run another subtract, and I'll plug the result of this burn over here, and let's preview the result. So this is what we have, and this is looking pretty cool. Of course, we would want to randomize this per tile. So again, I'll grab one of the setups here with the random mono. Let's grab this one and the multiply from the base shape, and let's copy these over here as well. And I'll plug let's reroute the burn output inside the multiply, and let's plug the blend inside the background for our multiply. So if I preview the final result and I turn this on and off, we can see what we get. And with this random mono here, we can control the ramp, and we can decide if we want to exclude more of our erosions per tile. So I can grab the first value here for our ramp, and I can push this further apart, and you can see, for example, how this middle piece will behave. If I grab this, I can start to get rid of the erosion, but I will leave this at the default values, and we can control where the erosion happens in our first ramp. So over here we can play around with this ramp, and maybe we can push the erosion further towards the edges. Let's preview our final result and go to this ramp here, and maybe if I grab the second handle on our ramp, we can see that this will push our erosion further down the tile, and if I grab the first one, this will now allow us to erode less of each tile. So maybe I want this, I don't want this erosion to be this strong, and maybe we can also go to our fractal noise settings while previewing this result, and we can play around with the amplitude. We can maybe introduce more roughness, and I can say that for now I'm happy with this result. We would have to introduce the colors and all of the other channels, and then we can come back to all of these settings and readjust. I would like to add one further layer here. Let's do after our burn, let's also grab just a simple multiply and multiply this with a copy of our fractal noise, and we might want to use a different offset here. Let's plug this and see what we get. So we just add an extra layer of noise on top of our eroded part, and maybe we want to increase the roughness, and for this one I want to decrease the element size. Let's do 0.035, should be good, and this should be fine for our erosion. Let's preview the final result. Alright, this is looking pretty good. Let's grab all of these nodes, and I'll press Shift O, and let's rename this to erode tiles. And finally, I would also like to add some cracks per individual tiles. And again, here I will want to map a texture to our UVs. So let's copy this UV transform. Let's paste this over here. And for the texture that we want to map, let's drop down a fractal noise. And this one has a noise type here. If we set this to worldly cellular F2 minus F1 and reduce the roughness, we can see that we get this cool pattern that looks like cracks. And if we plug this UV inside the position, we can see now that this is mapped per tile. So we probably want to scale up our element size for the fractal noise. Let's go ahead and increase this quite a bit. Let's use maybe something like 0.65. It seems to be all right, and we want to randomize the UV scale per tile. So let's grab our scale min and let's push this in. Let's use maybe something like 0.28, and we'll increase the uniform scale. Let's do maybe from 0.3 to 1.2, should be enough variation. So this is looking pretty good. We might want to just increase the overall element size. So I will increase the element size here, maybe slightly more, and let's go back to our uniform scale min. Something like this should be good. And from here, what we want to do is create the same sort of distort by slope that we created here for our border erode. So if we look at this, this is what we want. In fact, we can just copy this node combination. Let's copy and paste this over here, and we'll plug the result we currently have. And we can see that with this distort by slope on top, we get a really cool result. And we can go to our fractal noise here, and for this one we probably want to use the same worldly cellular noise, but I'll just reduce the roughness slightly so we can take a look at the result. Maybe we can reduce the scale overall. We can see that as I start to increase this, we kind of get this really cool jagged edges on our cracks. So this is looking good. We will want to invert this result, so let's do a remap from here. We want our cracks to be white because we want to subtract them from our main chain. So I'll do output min 1 and output input max 0, and we might want to play around with input max as well. We can do something like this, and we can also play around with our ramp. I can set this to a B-spline, and I want to have a kind of like a sharp center in the border here. So let's just increase the contrast, which is basically what we are doing here. So something like this is starting to look pretty good, and we would want to use the same multiply by random tile to have less effect of these cracks per tile. So we'll grab the random mono and the multiply from our arrow tiles. Let's copy these and let's paste them over here. And we will want to randomize the seed for this as well. So let's just use a different seed. We can play around with the ramp here as well. We can see what kind of results we get, but I think I'm just going to leave this at the default linear ramp. So we can go ahead and subtract this as well. Let's grab our nodes before the clamp. We'll do a subtract and let's plug the result of these cracks and see what we end up with. So with our cracks on top, we can see these over here. So if I were to disable this node, this is the result that we get. Now we might want to go to our remap and we can probably push our values higher. So I can grab the output mean of this remap and I can just increase this value so our cracks go further inside. And we can see now in the same remap node, if I were to play around with this ramp, we can see how this affects kind of like the fading of our cracks, which is really cool, and we definitely want to control this feature. So we are starting to get a pretty good result, I would say. We can play around with the roughness probably of our distort by slope. So if we go to the fractal noise here and increase the roughness, we can introduce overall more noise, but maybe we don't want this necessarily for our cracks. We might as well change the element size here. And I think this is now starting to look pretty good. And at this point, I believe we can start to blend this with a ground. So for the ground dirt, we are just going to use a couple of simple noise patterns and blend it with our tiles based on their height. So let's go ahead and let's grab all of these nodes first, and this can be our cracks. So for our ground dirt, let's start, we'll do our blending after the clamp. So let's drop down a fractal noise and we can plug this directly in our height to see the default result. We can use this as sort of like a base noise, and we can duplicate this and combine this with a higher frequency noise with a multiply. So for the second layer of noise, let's go ahead and first of all change the offset and let's isolate this. We might want to just increase the element size and also the roughness quite a bit. We might want to drop down the overall amplitude. So this is the result that we have, and we can spend a lot more time on making this ground dirt really interesting. So we can probably layer more noise patterns to get a more interesting result. But in this case, since the tiles are sort of the main feature that I want to show, I don't think it's worth spending too much time on this simple ground dirt layer. So to combine these, we can grab our clamp. So these are our tiles. We'll do a blend and we want to blend this with our ground dirt layer. Let's plug this in the background and let's also do a network box around this and let's call this ground dirt. So what we want to do is blend this by height. We basically want to merge these two results. We want to do a Boolean union. And when we want to create a union like this in terms of designing textures, we have to use the mode here. We can use maximum. So now if we plug this in our height, we are not going to get the result that we want right away, but now we can sort of start to see our tiles coming through from our ground. So all we have to do really is do a remap on our multiply and just drop down the output max to a value that suits us. So if I look at my texture, I can probably decide where I want the ground to start. We can do something like this. We can also, if I drop the input mean, we can increase the contrast slightly. So you can also choose to do that if you want, but let's maybe just lower this contrast and and something like this will be fine. We will need to add our color textures first of all, and then we'll be able to tell how our ground looks. We can also see maybe some of these tiles are a little bit too smooth. We can go to our base shape here and just increase the value of our noise. I'll go to the remap here, and maybe I can decrease the output mean here. Maybe I can also decrease the output max so we get a stronger contrast. And maybe overall for our noise I can increase the roughness, just so I get rid of a little bit of this smoothness on some of these styles. So something like this is starting to look alright. We can see some problems here with a little bit of these borders protruding between our ramps. Let's go ahead and take a look, and we can see if I preview this subtract result, we see the problem over here where the result of our base shapes has this sort of white border around our tiles. So this white gap, if we look at this result from our multiply. So we just really want to bring the mask of our tiles. So if you look at our tile pattern, we can just multiply our base shapes by this result. So let's drop down a multiply and let's grab our tiles, the first output here, and we'll plug this inside our multiply. And now this will get rid of our white gap between the tiles. So let's plug this here, maybe expand the network box, and let's plug this in our subtract. And now we can see we get the correct result. We can now start to work on the colors. Let's first create a base color for both our tiles and our ground. Let's start with the tiles. So we'll drop a fractal noise, and from here we'll do a mono to RGB, so we can map these black to white values to some different colors here. Let's start maybe with something like a very desaturated blue. I'm gonna try to use some colors between blue and white, so we'll add one more in the middle here. We might want to reduce the saturation here and the value, so we can start to see some different shades going on. And maybe we can experiment by adding one more here. Maybe we can start to introduce a little bit of yellow as well. So I'm going purely by feel. We'll have to come back and readjust this ramp in a second, but let's say that this should be a good start. We might want actually less saturation in our first color here. And what I want to do now is something that works really well with rocky textures. Let's start by dropping down another fractal noise. I'm going to set this to Worldly Cellular F2 minus F1, and I'll increase this element size and we'll decrease the roughness, so we kind of get this basic Voronoi pattern. From here, we will do a distort by slope, and we will want to distort this by another fractal noise. Let's drop this here and we'll plug this in our height. Let's look at the result we have currently. So now I can go to my fractal noise and I can increase the roughness here, and we can kind of start to see as I increase the amplitude as well. Maybe we have to increase our, let's go to the distort here and let's increase the scale. Let's set this maybe to a value of 0.1, and maybe I'll go to the slope there here and just reduce the overall scale here instead. So what I want to do is we can see how this kind of creates these nice splashes of color with roughness around them from our noise. We might want to play around with the noise element size here as well, and the roughness. We want this really rough. We can kind of see the different results that we get. So this is a really cool detail to add on top of a rocky texture. So for example, if I go to the mono to RGB here and do an add and plug the result of our distort, this is what we get. And we might want to remap our distort values here. Let's go ahead and just increase the input max, and maybe we can also, or rather the input mean, and maybe we can also play around with the input max so we can kind of get a little bit more contrast. So now this is the result that we get. And maybe overall I would want to go to the fractal noise here and just increase this pattern slightly. We can go to the slope there now and increase the scale as well if we want to add more roughness, but we want to preserve a little bit of these jagged edges in this layer. So this is what I'm going for. Now again, this will be still fairly basic. We can really start to layer a lot of random noises here, but one more thing that I'll probably do is drop down a fractal noise and just multiply this result. So let's drop this here and go to our fractal noise, maybe just increase the roughness and I can play around with the contrast. Maybe we don't want as much. And maybe we can also play around with the amplitude. So we can get something like this should be fine. I can also play around with this mask value. So it's not as strong, but something like this I think will be fine for our tiles color and for our ground. So let's first of all go ahead and put all of these in a network box, and this will be our tiles color. And for our ground, we'll do something similar. Let's start with a fractal noise and a mono to RGB. I'll duplicate them below, and for our pattern here, we might want to, let's first of all change the offset of this noise and maybe increase the element size. We'll go to the mono to RGB, and we want to use some dark brown colors and maybe some desaturated yellows here for our ground. Let's add a couple more, introduce some white, drop down the value. We want this to be fairly dark, so we can maybe do something like this, but maybe for our element size here, let's drop this quite a bit. We want this to be a lot more rough, and maybe I can play around more with some of these colors, maybe bring back a little bit of saturation. And let's go ahead and multiply this with another fractal noise pattern and see what we get. And with this second copy here, let's increase the roughness. I might want to decrease the scale, and we can play around with the amplitude and contrast. So we end up with something like this. Probably should be all right. We'll definitely come back and readjust some of these values, or maybe not, maybe just increase the roughness. But let's say that this is our dirt. We'll do a network box here as well. So this is our dirt color. So now we want to blend our tile color with our dirt color. So what we can do is grab the result of our height. Let's make some room, and this clamp result over here, we can see that this is basically the height of our tiles. So similarly to how we used a maximum here to blend between the ground dirt height and our tiles height, we can just use this one inside a blend node as well. So let's first drop down a blend between our tile and our dirt color, and we'll use as a mask, we'll point this to our clamp result over here. So let's plug this here and let's see what we get. And by default, we have the reverse effect happening. So let's plug our dirt color as the first input. So we'll plug this as our foreground, and we'll use the tiles as our background. So now we kind of get the result that we want, but we will have to increase the contrast of our mask. So I'll grab this result here, this wire that goes from our clamp. Let's do a remap, and if I squeeze these values now, if I decrease the output max, we can start to get a little bit more of our tile color back. So this is what we want. We just want to increase the contrast of our height. So this is starting to look pretty good. And usually for color, I always like to introduce a little bit of the detail from our height map. So if we go to our blend result here for our height, let's maybe drop down a null, and let's rename this to out height. We can also color this in a different way. I usually like to use red. So from our height, we can generate an ambient occlusion layer. So let's grab this and let's do a height to ambient occlusion. And I'll set this height scale here to 1. We can see this will give us shadows wherever we have low height. So in between our cracks and in between the tiles. And we also have a lot of detail here that highlights our curvature. We can play around with some of these settings, but usually 90% of cases, I like to leave these as they are. So with this height to ambient occlusion layer, we can go to our blend of our color, and we can do a multiply. And let's bring this over here in this multiply, and this is the result that we get. So with this layer, we can really easily add a lot of detail on our color layer. So we can also do a ramp, or rather a remap on our height to ambient occlusion, and we can play around with the min and max values here. Maybe we don't want this to be as harsh. I can also maybe increase the output min if I want less of my AO layer to affect the color. But we can see that this adds really a lot of detail, and this height to ambient occlusion is really useful. So this is probably used in maybe all of the textures that you're going to create. Now with our color, we can plug this in our base color, and let's preview this on our actual surface. So it's looking pretty good, not super happy with our dirt material. One easy thing that we can do is use an HSV adjust after our multiply here, so I can just play around with the overall values of this color. I can maybe reduce the value scale and maybe desaturate this slightly. I can play around with the hue shift as well. Maybe I can push this in the negative ranges to get a little bit more red overall. Maybe also play around with the value shift. So with this HSV adjust, we can try to balance our layers a little bit better, but probably we would have to go to our mono to RGB here, and probably here is where we have to make our changes. We can grab some of these colors here, maybe overall introduce more saturation and maybe also more roughness, but maybe at this point it's worth setting this to our 4K resolutions. So we can go up and we'll go to our CopNet and let's set the default resolution here. We'll use 4K. So now if I go inside, this will take a second to recook, as you can see. I'm not sure how noticeable this is, but now we do have a higher quality on our texture. Maybe overall I'm just going to reduce the value of this ground dirt. And actually you can see that our texture popped, so we had to readjust any of these values, and this forced our texture to reevaluate that the 4K resolution that we set. So now we are getting those very sharp details, and I'm really liking how this looks. And really we can now start to look into all of these setups and decide exactly what needs to happen. So I can go all the way back to our base shape and I can maybe just increase the lowest point here on our slope, so I can bring this slightly up. Let's maybe increase this value here. We'll try 0.2. So now this will bump all of our tiles up slightly. Maybe we can use 0.3. All right, so this is starting to look better. Now, the reason that this is cooking so slowly, I found that if this is happening to you, I found that this height to ambient occlusion is pretty heavy. So while we are working on these changes, I can go ahead and grab all of these nodes with this height to ambient occlusion, and I can press Q to bypass them for now, and we can go back now, and hopefully we should be able to work a little bit faster. We can also, back in our base shape, we can play around with these values as well, and maybe I can also bring everything slightly up. We can of course play with random seeds here for our UV transform, so I can try a different seed for our slope. And again, we can go in each of these layers and do any adjusting and spend a lot of time to make this really good. Now, finally, let's go ahead and reactivate our height to ambient occlusion. And we also want to use this layer to drive our roughness. So from here, we'll do another remap, and we want to invert this. So let's do output min 1 and output max 0, meaning that wherever we have these white areas, we will have a higher roughness. Now, we still don't want any of these really dark areas. We want to maintain an overall roughness across our texture, so I'll grab the output max and just increase this slightly to maybe something like this, so I can plug this in our roughness. Now inside Cops we are not going to be able to preview this roughness that well, so we can see that whether I have this here or not, we kind of have the same result. So the roughness inside this preview material, it's not that great for now. And one other texture that we want to generate, so this will be our roughness. Let's go ahead and start to create our outputs here. This will be our out roughness, and let's copy this. This will be our color over here after our multiply. So we'll do out color. And one final texture that we need, let's go ahead and create another duplicate of this. From our height, we want to use this to also generate a normal map. So let's do a height to normal. And by default, this height scale is quite high. I usually set this at a lower value. Let's try 0.1. So now, judging from experience, this is more like what a normal map should look like. So I can go ahead and plug this in our out node, and this will be our out normal. So this is our texture. We have everything we need, and we can go ahead and export this. If we wanted to render in a different software, all we would have to do is do a ROP image output. We can select what we want to export. So if I want to export the color, I would grab this node and I can copy this, so we can paste our path over here. We can see now that this creates this connection between our ROP and the node, and we can select our path over here. We can export this in our 4K resolution. Let's set this to 4K. And we can select our color space. Open color IO should be good. And here I would use TGA or PNG usually. So then we could render to disk, and this will save out a file that we can use in any software. But what we are going to do is not save the textures, and instead we are just going to link them directly from our COP network. So we can go ahead and create a simple scene in Solaris using this material. So let's go ahead and bring this material over into LOPS, and we are going to grab all of the out nodes we have here for the color, roughness, height and normal, and we'll start with our color. So I'm just going to grab this node and Control C to copy this. Let's head over to the LOPS stage. So I'm holding down N on my keyboard and I will jump into the stage context, and here we can just simply start by placing down a grid, and we'll make this grid a little bit bigger. Let's step inside, and in the sub context here I'll set this to maybe 100 by 100, and I will also increase the rows and columns here. Let's try 200 by 200, just so we have a little bit of resolution, because we are going to displace this terrain slightly. And before displacing the grid, we want to make sure that we have UVs, so I will drop down a UV texture, and if I turn on my UV display we can see this here. Now I want to tile the texture, so let's try a 10 by 10 by 10 value here for the scale, and this will essentially tile our texture 10 times. And now we can do our displacement, and we can just start with a simple mountain. Let's maybe disable the UV preview for now, and I will increase the element size and just increase the amplitude slightly, maybe increase the element size even more, and let's make this a lot less rough, and maybe just increase the element size even more. So essentially what's going to happen here is we are going to overlay a simple grid on top of this, which will be our water, and this is just to add a little bit more visual interest to the scene, just so we are not working with only a grid that has our material. Of course, this is completely optional. I'm just doing this to create a nicer render. And I also just want to show you a couple of cool tricks that you can do if you want to add sort of like puddles to your terrain materials. So from here, let's go up, and this will be our ground. Let's maybe just rename this. And also here, I'm going to switch this to one of my Solaris desktops that I have. And this desktop has my scene graph here on the left, and just the stage and the parameter window on the right, and of course the viewport in the middle. But it's mostly the scene graph that I'm interested in at this point. And maybe here let's do split pane top left. I will press P, and over here I will set this stage. Let's set this to the parameter window. All right, so with our ground, let's place this inside. Let's do geo and let's do ground, and let's straight away do a material library and create our ground material. So we'll step inside and we'll drop down a Karma material builder, and we'll rename this one to ground. Let's step inside and let's start by dropping down. Let's get rid of the inputs. We will drop down MTLX image, and in the file name here I will paste the path to the node that we copied from our COPNet. And before this path, we will have to use the syntax here, OP colon. So whenever we are referencing nodes from our COPNet, we have to use this OP syntax before our actual path in order for this to work. So now if I plug this in our base and in our base color, let's go ahead, let's get rid of the material properties for now. Let's go up, and let's go up one more time. Let's autofill materials and assign to geometry, and we will assign this to our geo and our ground. So here we see our materials now, and we can see that the tiling works. So we can keep going with our material. We'll go back inside. Let's go ahead and let's just duplicate this MTLX image node. And here let's use our next one, which will be our roughness. So we will point this to our out roughness node, and this should be a float signature, and we will plug this one in our specular and specular roughness. All right, and moving forward, let's do one more duplicate, and let's bring in our out normal. This signature here should be a vector tree, and this one has to be plugged inside a MTLX normal map first, and then the result of this can be plugged inside the geometry and inside the normal. And let's also use our height as well, so we'll do another duplicate, and this one will be our out height, and this signature should be a simple float. And this one we can plug directly inside our displacement, and we already see this in our viewport at a lower resolution. So let's go ahead, and for the scale here, let's drop this down. I probably want to use somewhere around a value of 0.1 or maybe 0.15, and we'll have to do it some test renders in a bit. But let's first go up and let's just assign a Karma physical sky, so we have a simple light in our scene. And also we can drop down a camera from here, and let's preview this camera and lock the camera, and let's choose a nice angle here. Let's maybe go to the view here, and let's make this angle a little bit wider. We can use something like a focal length of 26, and maybe we can close our scene graph for now. So we can start doing subtest render. Let's set this to Karma XPU and see what we get. And also I will hide the icon for our sky objects. So not bad. Probably our normal map is a little bit too strong. So we'll have to step back inside our material to adjust some settings. Let's first go to our Karma physical sky, and let's choose a cooler angle here, and also maybe increase the exposure a bit. So I will drop down the altitude. Let's increase the angular size as well to soften up the shadows, and let's maybe spin our sun around so we have a little bit more of an interesting result. Maybe we can do something like this, and let's step back inside the material, and let's go to our normal map, and perhaps we can scale this down slightly, and let's refresh our render, restart render. So probably our normals were too strong. This is the default value of 1, might be a little bit too strong. We can use maybe 0.2. So this looks a little bit better, and maybe we can also increase the displacement amount. We can try 0.25, and this is looking pretty good. Now, of course, at this point we can still go back in our CopNet and do changes to our materials, and we would see those changes updated when we step over back into Solaris. So we can keep things fairly procedural this way. So this is how we can set up the material, and let's add a little bit of that puddle that I was talking about. So it's fairly simple to do this. We can go up. Let's go up one more time, and let's do another grid over here to the side. Let's rename this one to water, and I'll place this inside geo/water, and we want to do another material library. Let's step inside and let's drop down a Karma material builder and rename this one to water. So for the water shader, we'll keep things fairly simple. Let's go ahead and get rid of everything except our standard surface here, and I'll set the base color here to 0. I'll go in the specular and set the roughness to 0, and index of refraction for water is somewhere around 1.3. And one final thing that we have to add here as well, in the transmission we will set this all the way up to 1, so this will mean that it's fully transparent, and we can go up and let's assign this, let's autofill materials and assign this to our geo and inside our water object. So now we can simply do a merge between these two objects, so we can see this here, and here we can now start to see our water, and we actually need to, let's step in inside our sub create for the water, and let's also make this 100 by 100. And in this case for the water, the subdivisions don't really matter. We can keep these at 10 by 10. So if I go up, we can now start to see some of this puddle thing happening here. So we can further play around with our sky from here. We can also add a dome light and use an HDRI, and we would probably get a better result this way. We can also maybe drop the altitude of the sun, and this is the result that we get. Now generally when we want to combine water materials, or this sort of like a puddle on top of another material like our tiles, we would need a lot more specularity where our water would sort of touch our ground. So to introduce this specularity, we can set up an attribute on the ground geometry to help us drive our roughness. So what we can do is we can step back inside our SOP ground, and from here we can drop down an attribute VOP. Let's rename this one to set water level. And let's step inside and we'll grab our position. Let's split this so we can have access to the Y value of our position. So we'll do a vector to float and we'll grab this middle value and we can use a fit range. And if I plug this inside the CD, we can start to preview how our values would look like. So we want the values that are below 0 to have a stronger water level value. So I will just reverse the destination min and max, and maybe for the source min, or rather the source max, I will drop this down quite a bit, and maybe even the source min I can drop this as well. So now we can see that where we have these really white areas, our ground will be less rough. So we can export this to a attribute. Let's do a bind export and let's rename this one to, let's just do simply water, but we will know this will be referring to our water level and we don't need our connection with the CD anymore. So let's go up and let's do an output here as well. So we are always exporting this last node to the Solaris context. So let's go up one more time, and now inside of our material library we can step back inside and we can bring in our attribute that we created by using a USD primvar reader, and this is a float signature, and we'll just type the var name here to water. And for example, if I were to replace this with our specular roughness, we can do, let's press Shift R and do a test render, and currently we have the reverse effect of what we want, where we have rough values wherever we have water. So we want the reverse of this. We can even preview this value if I select my USD primvar reader and press X. Since this is connected with our standard surface and being exported to the top level, we can start to see, maybe we'll unlock our camera, we can actually see our water level value. So we can remap these values straight inside of our material X, so we don't have to do this at the top level. Let's drop down a remap, so MTLX remap, and we'll do 1 and 0. So now we simply want to combine this with our original roughness. So from our MTLX image here, let's drop down an MTLX multiply and multiply this with our water level setup here, and we'll plug this inside our specular, or rather our specular roughness. So now we can see that right around our puddle areas, let's give this a second, right around our puddle areas and inside our water, we have a more reflective surface. And in fact, if I were to just preview this without the water, we should be able to see this a lot better, and we can see the result that we get. We can kind of already start to feel, even without the water, that this surface here is wet. And we can also maybe use this water level attribute to modify our color as well. So what we can do, if we step back inside the material, let's maybe make some room over here and arrange these nodes. So we can use the remap here to multiply our color as well. So from our color MTLX image, we'll use the same remap value, and if we plug this here, we should see these areas a lot darker. And let's again give this a second, and we can see the result now. So even without our actual water geometry, we can get a pretty cool result. Now maybe this is too much, so maybe with this value for the color, we'll do another remap, and we can increase the outlow maybe to 0.5, so we don't have this color that's super dark where we have the puddles. We just want to lower the overall base color ever so slightly. So I'm pretty happy with this result. We can go up and we can enable back our water geometry, and maybe for the water geometry I might just want to drop overall the height of this water plane. So maybe I'll drop down the translate Y maybe a little bit to -0.2. So we have a little bit of this wet area right around our puddles, and then we transition into the actual water geometry. So I'm pretty happy with this result. So I hope this was helpful, and if you want to learn Houdini, don't forget to check out voxsite.com. I hope you enjoyed this tutorial, and I will see you in the next tutorial.